to Agora Math Circle's Senior Beginner Lecture Note video. My name is Joe, and today we're going to look at algebra. So first we'll go over some algebra review, so we'll look at some terms. Next we'll look at systems of equations. Then we'll look at basic quadratic equations. And finally we'll look at functions. And in each of these concepts we'll look at some algebra too that is incorporated as well. So now let's review some algebraic terms. To begin, algebraic expression. An algebraic expression is just like an equation, but it's without an equals, greater than, or less than sign. For example, 7x plus 4. This is an algebraic expression. Next, algebraic equation. So, you can guess, it's just like an algebraic expression, but it's with an equals, greater than, or less than sign, and may have a variable. So 7x plus 4 equals 18. And this x right here is a variable. See, a variable is any letter that is being used to take place of a number. And usually, what you want to do is solve for the variable, or find the answer, or what the variable equals, in an algebraic expression. And so, also, a variable can be any letter from A through Z. The most common variables are usually A, B, C, D, and then X, Y, and Z. So now let's move on to system of equations. So a system of equations are multiple equations that have the same solution. That means, if you have two variables in them, for example, x and y, x will always equal one number and y will always equal another number in both equations. This right here is a system of equations. We have x plus y equals 3 and 2x plus 3y equals 8. Now we need to find what x is and then what y is. If this was just one equation, it would be really hard because x could equal 1 and y would equal 2, or x would equal 3 and y could equal 0. We would never know. But then because we have two, we can solve and using these three ways to find what x is and what y is. So the first way to solve is by graphing. So for this, you'll need to know how to put these equations into the graphing form, or y equals mx plus b. And this you'll learn more in depth in algebra. So in y equals mx plus b, you'll have y on the other side of the equal sign, and then mx plus b on the opposite side. So this allows us to put any number for x and get an output y. So whatever x is, we'll graph on the x part of the graph, x-axis, and whatever y is, we'll graph on the y-axis of the graph and get a point, which will give us an ordered pair, where it's x, comma, y. So, to put these two different equations into graphing form, I need to make sure that their y is on this side, and the rest of the equation is on that side, with mx plus b. And m can be any constant. So it can be -1, which just means that it can be negative x, or it can be -3, whatever is a constant. So, and you'll learn later in algebra that also the plus b is the y-intercept. That means that when x equals 0, the point would just be b, y. So for our first equation, we're going to move the equation around and get y equals -x plus 3 in mx plus b form. And then for the other equation, we move things around and we divide here and there. We get y equals -2/3 x plus 8/3. So now if you already know how to graph these two equations using their y-intercepts and their slopes, you can just put it on a graph and graph the two, and you'll get the answer of where they meet as 1, 2, x, y, so that means x equals 1 and y equals 2. Or what you can do is plug in numbers for x and then get numbers for y. Same for the other equation. Plug in numbers for x, get answers for y. So I only did 0, 1, and 2, but you can go all the way up till 10, 20, 100, whatever you need to make sure that you can find enough space for where both lines cross. So this right here shows that they cross in one place. That means they have one solution, which means that x always is going to equal 1 and y is always going to equal 2. And we can also check by plugging in these numbers back in the equation to see if they work. So next we have substitution. So for this, we'll also need to rearrange the equations a little. This time we just want any variable, either x or y, to equal whatever the rest of the equation is. So what I did is I rearranged this first equation, x plus y equals 3. So I just moved everything around, so then it said x equals 3 minus y. Then, since I knew that x equals whatever this is, I substituted that into the other equation, 2x plus 3y. So whatever x says, I put this in, as seen right here. Then I just distribute and simplify the equation until I got y equals 2. And then once I got y equals 2, I plug that back in to the original equation, x equals 3 minus y, and got x equals 1. You can also plug into this equation to get the same answer. Next, we have elimination. And this is the most popular method, along with substitution. So first, I'm also going to not rearrange the equation, but change it a little. So first you want to align the equations so that x is aligned, y is aligned, and then the constants align. So if you might have to rearrange different equations if you get an equation in a different form, but for right here, everything is already set up for us. So I got x plus y equals 3, and then 2x plus 3y equals 8. So what I want to do is I want to pick a single variable that I want to eliminate, either x or y. So, and also what I want to do is I want to change the equation so that I can eliminate it. So I chose to eliminate x in this situation, and to do that, I had to multiply this whole equation by -2, so that when I added them up, they would cancel out and get 0. So I multiplied this whole equation by -2 to get -2x minus 2y equals -6. Remember, you have to multiply each term by -2. So after adding the equations up vertically, I got y equals 2. Then I plugged that into the original equation and got x equals 1. So those are 3 ways to solve systems of equations. Now, there are 2 different scenarios that can happen if you can't find a single solution for a system of equations. First, when the equations equal each other, you could have infinite solutions. This basically means that the lines, when graphed, are on top of each other directly, so that each point meets with each other. For example, in x plus y equals 8 and y plus x equals 8, you can obviously see that these 2 equations equal each other. So their lines are going to be on top of each other and just cross every point with each other. Next, when both terms of the equations cancel out, or when the equation is not possible, for example, if you get n 9 equals 0 or something, then that means that the 2 lines, if graphed, are going to be parallel and never meet, which means there's no solution. This, for example, right here, y equals 2x plus 1 and y equals 2x plus 4, are obviously parallel because we know that the y never going to equal each other and the x are never going to equal each other. So these are 2 parallel lines and they never meet. So now let's move on to the basic quadratic equation. So this right here is a quadratic equation. ax squared plus bx plus c. Now a, b, and c are all going to be numbers. A and b will be coefficients and c will be a constant, which means they'll be a standalone number. So to find the answers for these, first thing you need to do is identify what each constant and coefficient is. For example, what a equals, what b equals, and what c equals, and then plug them into this equation. This is the official quadratic formula. Minus b plus or minus the square root of b squared minus 4ac all over 2a. It's really important to memorize this for Algebra 1 and Algebra 2. So what you want to do is find a, b, and c and plug them into this equation. And that's what we're going to do with this example right here. So 2x squared minus 3x minus 4. We're going to find what a, b, and c equals. So a equals 2, b equals -3, and c equals -4. Next, we're going to plug them into the equation, where we get negative times -3 plus or minus the square root of -3 squared minus 4 times 2 times -4 over 2 times 2. And we're going to keep simplifying this until we get our answer right here. X equals 3 plus the square root of 41 over 4, and x equals 3 minus the square root of 41 over 4. So this means that x has 2 different solutions. Now, to find out if your answer has 2, 1, or 0 solutions, you can check using the discriminant. So the discriminant is this section of the quadratic formula, b squared minus 4ac. So when you graph the quadratic formula, you should get a parabola like this, usually. And what you will do is you either find 2 solutions where they cross the x-axis, 1 solution where it crosses the x-axis only right at its vertex, meaning right at its bottom, once, or no solutions where it doesn't cross the x-axis at all. This means that the solutions might be imaginary or not real. So when d is less than 0, or the discriminant is less than 0, that means you have no real solutions. That means the graph doesn't cross the x-axis at all, as shown by this graph right here. Next, you can have d equals 0. That means you have 1 real solution. It crosses the x-axis once, and that's at its vertex, or its bottommost point. Next, we have d is greater than 0, which gives us 2 real solutions. That means that a graph crosses the x-axis twice, here and here. So now let's look at functions. So in functions, you have a domain and range. So a domain is a set of x values, and a range is a set of y values that satisfy the function. For example, let's look at these 2 sets of x values and y values. This right here is the x values, so 1, 2, 3, and 2, and these are the y values, 6, 7, 8, and 9. So this right here is not a function because you have the value of x repeating twice and equaling two different y values, which means that it's not a function. This set, however, where you have 1, 7, and 6, and 3, 2, 4, you only have a single x equaling a single y, which means that this is a function. Now, if you had multiple y's equaling different x's, for example, or the same y equaling different x's, for example, if you have the values of 1 and 3, and then also the value of 2 and 3, that also means it's a function. But you just can't have the x repeat and equal different values of y. So, when you're writing domain and range, you want to use interval notation. This means basically that when you have a bracket, it means you include the number on the on my right, and if you have a parentheses, you don't include the number on my left. So this means right here, let's say this is for a domain, this means that all the x values are from 6 to 10, including 6 and not including 10. So now you can check if a number is a function by using the vertical line test on a graph. So the important thing is that you can't have x values repeat. That means that if there's any point when you use the vertical line test where you see two values for y on the same x, that means that it is not a function. So what I'm going to do is use a marker. You can use a pencil or your finger if you want, and just go across the graph and see if there's any point where there's a single x but multiple y's. And as you can see, there are on this graph, which means that it's not a function. Now let's try this graph. If we just keep going, no, never meet. So yes, it's a function. And right here, there's not a single point where they meet, so yes, it's a function. So thank you so much for watching. I hope you enjoyed the video, and please don't forget to like and subscribe. Thank you.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramatcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!